We have a very interesting panel set up. So you see the lovely faces on the dais, and you see the topic. You know what's going to upcome. So I hope you guys have a lot of questions. We'll try and accommodate most of them. But overview, the discussion is around how ROS is being implemented within industrial AMRs, how we're using it to sort of boost productivity. What are the challenges on the way? Because of course, all's never smooth. So we discuss the challenge. We'll address how the folks here have sort of overcome it and hear it from them itself. So let's give a huge round of applause. Let's welcome all of our panelists, and we look forward to hear everything that you guys have to say. All the best. Thank you.
Yeah.
Like a quick intro.
Okay, sure. So hello, good afternoon, everyone. It's an immense pleasure to be a part of ROSCON India here and moderating the panel, which is ROS, AMRs, and the industrial efficiency. So a short introduction about myself. I am Pranshu Tople. I am co-founder and CTO of RigBetel Labs, where we work to help other companies develop robotic products and solutions using our platforms. And the main mission of RigBetel Labs has always been supporting other companies and startups, MNCs majorly, to understand the potential of ROS, how they can use ROS and other tools to make better and efficient robots in their, which can face real world challenges. And that is what we do. So AMRs has been recently growing a lot in India, and here we are pleasure to have four innovators as well as founders of big companies who are heading the AMR industry in India. So I'll ask everybody to introduce themselves.
Yeah,
Okay. Tell about you.
Good afternoon, everyone. Firstly, this is amazing. Thanks to the whole team that's put Roscon together. My name is Sabah. I'm the CTO for Virya Autonomous Technologies. We are a Mini Group company. We build solutions that involve, autonomy being the primary tool to solve mobility problems. We do both people and material mobility. We've been playing with a lot of different things. We built India's first autonomous buggy for an airport operation that ran for about 7 months in Bangalore. And we've been a lot more focusing on material mobility of late. Specifically, we do tuggers, right, today. And when I say tuggers, robots that can pull anything, it can be one trolley, two trolleys, multiple trolleys, long distances, indoor, outdoor, up to 5 tons, and a lot more coming up in the pipeline. For Virya, in short, the mission's been how do we solve mobility problems with autonomy, but not just sell robots as products, but truly do the end-to-end solution. So when we go to a customer, it's never about how many robots do you want to buy, but it's more what exactly is the problem that we're trying to solve for you here. So yeah, looking forward to this panel, Pranshu. Thanks for setting it up.
Over to you, Runal.
Thanks, Pranshu. Once again, as Sabha said, I second that. Thank you so much for conducting such a beautiful program and for the years of effort. My name is Runal Dahiwade. I'm from Peppermint Robotics. We are a full-stack robotics company based out of Pune, making robots for a few applications. Commercial cleaning is our primary application that we cater to. Happy to learn a lot and happy to share whatever I can, and looking forward to what we discuss.
Hi guys, good afternoon. Myself Pranavan, founder of Control1.ai. So we are building an operating system which can turn your regular slow-moving equipments into a physical AI agent. So unlike pre-programmed machines, our systems tries to understand the environment and do things like how we humans do, learn using reinforcement learning, semantic learning, learn and do things. So what we are trying to build is like once you show the place and map the place and tell what place is what, the machine should be able to do the rest of the things. Just opposite to a pre-programmed machines. We're in early stages. Luckily, we got a few customers who are ready to experiment with us and see how they can leverage AI and robotics in their sectors. And yeah, thanks to the recent advancements in edge computing, edge AI. So our system entirely runs on inferencing. Yeah, that's what we're making. And yeah, most of the credit goes to the NVIDIA's recent development in edge computing too.
Yeah.
So yeah, this is what we do.
Over to you, Harsha.
Yeah. Hi. Good afternoon, everyone. Firstly, I would like to thank RigBetel Labs and Pranshu for organizing such meetups because it's quite a lot of challenge, but we need more of these to happen in India. So just to introduce myself, I'm Sriharsha. I'm the co-founder and CTO of Bullwork Mobility. So we are a startup. We are about 3 years old, based out of Bangalore, and we are focusing on giving complete solutions for utility segment. So when I say utility segment, I'm talking about areas like agriculture, construction, mining. So we are developing the entire ecosystem. That means from the vehicle to move away from diesel to battery-operated vehicles. For example, our flagship is an electric tractor that is in development at the moment. And for the automation bit, once it's electric and once the vehicles are drive-by-wire, it's a lot more straightforward to kind of move into how do I automate this repetitive tasks that is happening. But where we are kind of seeing this as how do we provide a low-cost automation solution so that a farmer in India not only moves away from paying a lot of diesel expense per year, but free himself to do more productive tasks while the vehicle is taking care of some of these repetitive tasks that is there. So yeah, happy to be part of this panel and this event as well.
Thank you very much for your introductions. It was really exciting to see robots are used in so many different areas, right from industrial automation, material handling, cleaning, and as well as helping our farmers be more productive in sense. So I want to understand, like India is right now growing in the robotics community. Like in the keynote from Joffrey, we understood that India is one of the 3 most used countries that are using ROS, right after USA and China. So that makes us the global hub for robotics soon. So how does your companies use ROS? What inspired you to ROS in your solutions? Can you one by one tell us about it?
Harsha, do you want to go first?
Yeah, sure. So as I said, right, our main focus was we wanted to do a low-cost solution. Low-cost, we're not targeting, say, an L4, L5 automation. We are looking at how do you automate vehicles which are slow-moving again in a very controlled environments, like in a farm. You're not going on the road. So we started our journey, through a little bit of ROS, in-house. Then we had this, sort of thought, okay, now ROS is, everything is happening on the edge for us, and ROS is a big overhead that's coming on. Can we move away from it? So we spent a little bit of time, maybe a year, trying to fiddle out with, writing our own middlewares and trying to optimize. But, at the end of the day, I mean, that's something that we are learning out as well. We realized that, the amount of efficiency gains in terms of performance that you get is a little, I would say the trade-off is not the right, because the amount of leverage that you get using pre-packaged ROS nodes to try out things faster is that's a trade-off that you always want to take. So we fiddled inside with our own stack, writing our own middleware, communication, IPCs and all. And now we are kind of again trying to transition back. We found some success, with that sort of a thing, but again, we're starting transition back into the ROS2 community just to make sure and we can leverage and try out different nodes that are already, that are already there. And I would say that has been quite a interesting journey trying to make things on our own and again coming back to ROS. So yeah.
Well, of course, for us, apart from the inferencing part, everything runs on ROS. So I cannot say that, hey, these are areas where ROS is used. I mean, everywhere. Peripheral communication, CAM, sensors, everything runs on basically the communication ROS. And we're entirely using ROS stacks. And the best part, as Sriharsha mentioned, community-driven, used globally, and the packages helps us to focus on to what we are trying to do. In our case, basically, we are specifically focusing on understanding perceptions and vision systems. So ROS helps us predominantly in forgetting about other things. It's already built, stable, it works well, people have tested it, people have built and everything's ready. So we can focus on to our part. So it drastically helps in the faster GTM and focusing on to, as mentioned, focusing on to what we are supposed to do. So yeah, and the best part is community driven. So that helps a lot.
Runal?
So I sort of align to what Pranav Harsha said. Maybe let me bring another context to this, which is sort of not purely a tech context. We at Peppermint have a bias for speed. Yeah, we would rather do things fast, succeed fast, or fail fast. And if that is the context of our build cycles, we would rather focus on the application end of things. And ROS is such a mature framework. If robotics was a gold rush, ROS is the shovel that we all have.
True.
The general purpose shovel.
Yes.
Now we may wish for a hyper specialized shovel, but we would rather try to find gold, right?
True.
So I think everything what Harsha also said, the community around it, the packages and libraries are well tested, tried. It becomes a catalyst to move things fast. That's what makes us fall in love with it over and over again.
I
We
totally
went through
agree.
the pain from the transition 1 to 2. I don't know if Harshal's in the house. He's our CTO. And credit to the team. But yeah, we continue to be bullish about where this is headed.
I totally agree. What about you?
I think you guys pretty much covered it all. Just two takeaways, right? One is there's a strong sense of community, and we're a really small company. We are growing today, but we're very invested to not just take from the community, but really get into a mode where we're giving back to the community.
Understood.
So we have a lot of engineers that are very keen on let's build things from scratch, but let's not reinvent the wheel, right? And like Runal said, it's all about velocity, right? And there's no way you can get to that velocity without something that's so much of community driven and effort. So that's one. And two, for me, I've seen also, having spent a lot of time in the automotive space, I've seen the whole ROS one being used by every single autonomous vehicle development company in the world. And I've also seen them both succeed and fail, but I've realized that the differentiator there was everyone had the same set of ROS things, but it was all about what they did with it, right? So and to Pranav's point, right, ROS can help us focus on what we want to bring the edge on, right? And that's how we are looking at ROS today.
Great. I totally agree with you. Your experience at Rivian might help you with that. So all of you four guys are the manufacturers of autonomous mobile robots in India. So how do you differentiate yourself from the global competition? Do you think affordability is the key factor, or there is a part of innovation or something else? What do you guys think about it?
I'd say two things. One is there's an aspect of affordability. Inherently, we have that just in how we've all evolved in India, how we think about things. We're simple, we're frugal about a lot of things, but there's also, I think, a lot of value in design that's simple and elegant over design that's always complex. I think there's enough examples to say we can really do cutting edge things, but the cutting edge aspects have to be for things that matter. So I think differentiation for us is how do we do these simple things right and do that in an extremely cost effective manner and in a more sustainable and scalable manner. When we talk about scale, depending on the space you're in, this industry is in a space where today we talk in hundreds of numbers, every company, right? In terms of number of robots you want to build and sell and whatnot, but it's only a matter of time, right? And I think what's going to be a big differentiator is how are you architecting things today to scale in the next 2-3 years? Because there's enough cool tech out there. There are great things people can put together, amazing prototypes, demos, but the differentiation is, are you building a product that can really scale in terms of volume? And we have a bit of that advantage, I think, when we work out of India and do things here.
Fair, good points actually, Sabha. I would probably think of two contexts to your question. You said competition and cost. Our lens on both these stems from the customer and the core need of the customer. I'll give you a fairly isolated example. We could extrapolate that. In commercial cleaning robots, that's primarily our primary line of business. Our value proposition changes the moment the customer segment changes. Yeah. If we are cleaning an airport, we are surrounded by a very large support staff. A robot is playing a role of optimizing work and saving man hours. But if you're cleaning a stadium, there is no large support staff around. There we are automating an entire workflow. So if I have to extrapolate this, application A would need a faster, neater, cleaner, elegant cleaning productivity per unit time. In application B, it would need a docking station, auto charging, because there's no manpower around, right? At the middle of the night, there's no human in a stadium. So cost becomes a byproduct of what are we trying to sell to what kind of use case within the pyramid of what we actually do. And I think if we drill down to the nuances of the workflows, you'll realize not everyone is looking for everything. That therein lies the devil of the detail to optimize costs. Certifications and higher grade sensors or LiDARs, who needs it, who does not, battery backups. Battery is a huge cost of every robot by itself. Do you truly need thoroughbred, big steel chassis or not? You could work with lightweight plastic materials and so on. So compute needs. And so I think with India, we stand at this beautiful conjuncture of deep manufacturing ecosystem, competencies on one end, and deep understanding of software and control systems on the other end. These two hands could be joined. Very, very cost-effective solutions could be built, and that's what we are trying to do.
Very interesting. Pranav?
So, yeah, cost is one important factor that drives adoption of AMRs robotics into the market. I see the literacy rate has gone up, and it's really hard to find people to work repeated boring jobs. For example, typically we'll take our field itself, moving pallets, moving 150 pallets a day. It's a really boring job and physically strenuous. Like, just imagine, it's a high momentum vehicle. The acceleration is fast. You need to stop, pick materials, turn, move. So people opting for these kind of repeated boring jobs is really going down, because the good part is there is better opportunity coming for them on the other end, because as mentioned, the literacy rate has gone up, and people can be easily trained to do other works. And the interest towards these kind of physical works are going less, and industries are forced to go into automation. So this is a clear indication that industry will be and must be adopting automation, and people can be supervising these machines or helping these machines. On that note, of course, so the point that I missed to mention is, since the available labor is coming down, this means the company has spent more to get in, train, and make the person stay with the organization. So this is becoming difficult. Getting a person is one thing. Making them stay within the organization for these kind of repeated boring job is the next big thing. Retention. So this is another big factor which is driving automation, I would say, and there will be a huge boom here. So this is where, again, a beautiful conjecture where need for labor is going up, because as he also mentioned, India is becoming a manufacturing hub. Many industries are coming into the country, so it's going up. The labor availability is going down, and yeah, it is a beautiful era for robotics. And of course, autonomous machines, more intelligent machines are needed more into the market.
Harsha?
Yeah, sure. I mean, ultimately, it's all like,
How do you define?
if you are making an autonomous machine, who is your customer, right?
Yeah.
You need to sell it. I think Runal made a very nice segregation of those two, which I completely agree. Let me kind of just shed a little bit light on the agricultural side, right? So when we started Bullwork, we started talking to a lot of these rental agencies where they rent out tractors. And there are government-sponsored and subsidized areas called CHCs in India, where the rental cost is way low. So most of the farmers are kind of incentivized to rent from there. And we found out that farmers they have a backlog of about 2 weeks. So if you order it today, you're going to get a tractor rented out to you in 2 weeks' time. And there are tractors in the field, I mean, in the yard, but they couldn't find the right skilled driver, right? So it's slightly counterintuitive. We have a lot of population, but it's very hard to kind of find the right skill and as you know, as you're saying, like, making that labor or the skilled person stay. And you also have to think about, okay, what is the future trajectory of his role, right? What about 15 years later? What is he going to do? Is he still going to drive a tractor, right? So, there is this one aspect of finding the labor, doing the quality work, and doing that quality work consistently. So, making it autonomous, kind of solves these things. But I would say today, the Western market has a lot more value for startups like us. And a man-hour rate in America could be, I don't know, $12-15 an
Cost
hour.
arbitrage.
Cost of thing, right? In an agricultural scenario in India today, it's about $10 a day, right? So if you offset about 8 hours of work in a Western market, it's equivalent to offsetting about 10 days of work in India. So unless there is a lot of volume that comes out from Indian customers, right, there is always a better play to go and sell it to an American or an European customer. So this is where why we need to kind of quickly come out with cost-effective solution. I mean, the other parallel is mobile phones and our adoption right now. Even though the mobile phone is now expensive or almost international rates, or slightly more in sometimes, now everyone has it. So I feel like autonomous vehicle. Once there is that hockey stick thing that comes in, every company, medium, small, or large, would want to have some AMR solutions. And that's what we are kind of going towards too as well.
I totally agree with it.
Yeah.
Great. I have a question for Runal. So your robots are specifically into cleaning commercial spaces like airports, malls.
That's
so,
right.
but India is highly dynamic and often very chaotic space. So how do you ensure operational reliability in spaces like these where humans are almost everywhere, and how does dynamic obstacle avoidance and other factors play in your role?
So I would say every environment is chaotic, not just India. The way we prioritize looking at this is from a lens of safety comes first, productivity comes next, and performance comes last. That has been sort of our go-to. Why? Because as a robotics company, which is on the younger side compared to traditional companies who make cleaning equipment for decades, what we cannot afford is even the remotest edge case depleting the confidence of the users. There's no context to compare the robots with. All robotics companies put together, we are scratching the surface. So we made a choice that safety will come first. So, which means for heavy intensity environments like malls or railway stations and bus stops, and we do all these, and then it's the edge cases will go from people rushing towards a robot to a parent putting their child on top of our robot and clicking pictures, right? I mean, how do we predict this? There's no amount of preparation you can predict some of these things. So safety goes both ways for us. One is of the environment and people around and the assets around, and two, of our own asset. We better sustain all the abuse, friendly abuse. So that comes first. So we break down these scenarios into what kind of dynamism, how much of it is, how much of that can be accommodated with generic sensors that we could use, because that keeps the BOM sort of optimized. And in some cases, we have to go out of our way and put some special sensors in special positions, not leave blind spots, have redundancies in place. We do bus stands, and pigeon poop is a problem. Now, we couldn't have imagined this originally, right? No depth camera was designed for this. So now what do? So you have to sometimes make improvisations with covers guarding your LiDARs all the way to whatever you can do. So we look at safety lens first. We break it down into pockets. If there's a lot of glass, you have to go into ultrasonic sensors and so on. Optics don't work very well. If it is extremely dynamic environment like a warehouse, we even encourage our customers, rather I'd reword it. We educate and then encourage our customers to use artificial features. The question starts from, oh, hey, what is an artificial feature? Oh, you need this, then why was the robot here in the first place? It's a slippery slope of a... But then if we don't do it pragmatically, who would? So we divide the environments into severities, and then there is a cutoff point to that. Beyond certain severity, don't touch it. Yeah, because we have to choose our battles. Can't be solving everything for everyone. We do learn from those nays also as much as we learn from the yays. So that's one. Then comes productivity. Eventually, the robot was meant to do something there. Yeah, the core value proposition for us in the cleaning segment is the cleaning. How fastest it cleans, but how well it cleans that fast. We would rather clean well versus just clean it fast. Yeah, we don't want to do a second run or second pass, especially in cleaning where we have to do every square feet or a maximum percentage of the square feet that we cover. So I would say productivity goals come second. Once again, we relate this back to dynamism. Like, let's say a robot is zipping around here, and if we were doing a standing huddle or walking and talking, we would give it a severity rating. In fact, our deployment processes include color coding of every space. We do a red, green, blue, or whatever. We don't touch the reds. Blue, we educate, empower, and deploy. Greens, we are very comfortable with. So we actually go down to the lens of even ensuring various stakeholders, including the engineering R&D on the back end, which is in Pune for us. But on the front end, our operations colleagues, our ops team on the ground, our implementation team members on the ground also can take a call on the spot that what is worth a battle, what is not. What is worth a battle with some education. So that's where the productivity layer kicks into post the safety. Finally comes the wish lists of performance, and trust me, it's an infinite Excel sheet. It's a never-ending play, and it takes a lot of restraint to not go down that black hole of continuously making sophisticated software or control mechanism of safety for an edge case. So I would say chaos is going to be part of our life for the application we have chosen. We have to make our own rules, and we stick to the greens. We work on the blues, and we say no to the reds. So that's how we solve this.
So I have to ask Sabarish and Pranavan, are Indian industries as well chaotic? Do you face any challenges over there?
Oh.
Or is it clean?
Wonderfully chaotic. There's enough going on. I think I have a lot of my team members here that have spent multiple shifts at manufacturing facilities. There's all sorts of chaos. I mean, I can share a ton of examples, but we'll save that for after the session. So, Pranav.
So,
It's dynamic or chaotic. We can call it however we want. But but most of the processes are meant to work with people, and people cannot exactly do what they're supposed to do precisely, repeatedly. Probably they might do for a month or two, and then there's huge efforts needed to bring that repeatability, which is really tough, and which machines can do better. So, of course, when machines are trying to work with people, then that means the machines has to adopt that dynamism, else it can't work, because every time the scenario is not going to be the same. So if the premises is fully loaded with robots or machines, then probably everything can be predictable. But the moment human factor comes in, of course, there will be dynamism. And today's machines, if we are looking at large-scale deployments, rather than 1 or 2 robots getting deployed in a factory, if you're looking at large-scale deployment, of course, dynamism has to be there. So this is where AI can help us better.
So again, question to you. So you make tuggers primarily, right? So which is a lot different from the traditional AMRs where the payload is on top, whereas in your case, it's like a train. So instead of just one small area of footprint of your robot, you have a train footprint that you need to understand how will it act on turns. So is it difficult technically, or is it one and the same?
It's not one and the same. I think difficulty can be a perceived part depending on the problems you're all solving. I feel like everyone here is solving some amazing difficult problems. So it's different though. And if you fail to see the risks that come with tugging, then it can lead to a lot of really bad situations and scenarios, right? So we look at 3 big parts. One is from a path planning standpoint, right? How do we understand the kinematics of the whole system? What are we doing about it is one area we spend time on, right? From when you're, let's say, defining a route and you're defining the robot's path. Taking these into consideration is one thing. The second thing is, speaking of chaos, customers can tell you, I have 10 trolleys, they're all identical, built to spec, ABC. But these are robots that are running indoors and outdoors. They're running in all sorts of road conditions and etc. And these trolleys are never one and the same. I can tell you, there are trolleys with a pull to the left. There are trolleys that sometimes have a wheel that gets stuck. You run into all sorts of edge cases. So there's a lot that you put in effort from a path planning standpoint. Next comes your one of my favorite things is customers want all 3 trolleys to be able to perceive everything around them. If a human touches the last trolley, they expect the robot to stop. So we get all of these, right? So going back to what Pranav was saying, a tugging application today, when it's a manual driver driving, the guy's got like 2 mirrors. He's looking back sometimes, he's not looking back sometimes, and this is working today, right? Like, and there are accidents and things happening. So we've taken a 2-phase approach. Phase 1, we try to stick to operations where, like Runal said, some of these are the reds, right? Like if you have like a lot of man movement that it doesn't have sufficient visibility and blind spots, and you have a trolley or a set of trolleys turning, it's a risk condition you shouldn't be taking up until you have the ability to sense that. So we do a risk assessment as we go through that, and definitely factoring all of these variabilities, we make sure the sufficient padding on the sides are all defined appropriately. But the second part is we're working on some cool things where tomorrow on fixed extended trolley applications, how do you bring in sort of distributed sensing, right? And how do you set that up to at least protect some basic things and get feedback out to the mothership of sorts, right? Like for all purposes, like a trade. And the last part is from a fundamental system design standpoint. Your robot's fundamental lateral longitudinal vehicle performance is not going to be the same when you're tugging. And when you have 3 or 2 trailers with different payloads, braking especially can be quite interesting. What your diesel profiles are, and sort of depending on a loaded condition versus unloaded condition. Today, when we run with 5 tons and we're running at 10 kilometers per hour and we're on a rainy evening where there's just a wet surface, all of a sudden people want the equivalent of your automotive traction control system in place, right? But again, we're trying to bring in value in the right way. We get very creative with building systems and anticipating these aspects. So a lot of work has been going on the system design standpoint. So when you're tugging, you have to think about it ground up. If you build a robot that can carry and then you just say, I'll put a hook and a trailer and I'll run with it, then there are going to be edge cases. You're going to keep learning as you do things. So, yeah.
There's a question for Harsha. So I guess you had a very interesting journey with ROS. You started with ROS, left ROS, started your own stack, and now coming back to ROS. And you are the only one who are making outdoor UGVs, I can say, or AMRs in that sense. So can you tell, like I heard a lot of people like asked me in the complete the conference that why do you use ROS? Is the ROS the only option? So what would you like to say to those founders who are trying to figure out that?
I mean, if there is a founder who is trying to figure out this, I would say don't build a robot without ROS. I mean, like nothing's as good as getting first-hand experience on why a particular architecture is the way it is. As I said, right? So I see this as a learning from our end when we went in. So now we actually understand a lot more deeper aspects of ROS that sometimes we might skip over because everything is just working. You don't open the hood if everything is working. So as I said, right? So for us, our initial thought was we want to make a very low-cost hardware. Everything needs to run on the edge for us because you can be in a field, 50 kilometers away, from any major center of an urban center. Sometimes you might not even have an internet connection, so everything has to be self-contained. And for that, we thought, okay, we will have a lot better control because honestly, that was one of the challenges that we had initially when we started working with a lot more complicated stack nodes as well, say nav2 stack. Why was it the way it was done, right? So as a young company and a young team trying to get, I think the choice was correct for us initially to move away, try to get it done without it, because now you can start focusing a lot more on how to improve performance, why is it consuming that overhead? So a lot of these questions that comes in. Okay. But once we had that sort of understanding and started to appreciate this sort of packages, and obviously the community has spent thousands of hours working on that, it's thoroughly tested. And sometimes we feel like a particular application is not there. An outdoor agri-specific packages, I would say, are a little less compared to, say, an AMR industrial scenario, right? Because no one's doing a tractor with a rotavator attached. That is a different thing altogether. Because if it goes rogue, the tractor goes rogue. Now you already have a a 1-ton rotavator rotating at some 540 RPM, and you don't want to. That's a safety critical system as well. So what I mean to say is, like, moving away and understanding the depths of it and coming back. I think the ROS2 now has a lot more safety and industrial certification that is there. So the ROS community also has been working towards to making sure that it's not an academic project anymore. It's more of an industrial project where people will be selling machines based on it. So in that sense, ROS2 has matured. For example, Humble has matured. For production and for deployment. And once that is satisfied, those things are satisfied, nothing else like that. The second quick point is, now a lot more hardware is actually getting optimized for ROS as well, like the NVIDIA and Isaac ROS. So now there are custom packages which are making use of the accelerators. You're not dumping everything on the CPU. And for a small startup, that sort of an optimization is a hard bargain to kind of pass through as well. So if you're a founder, trying to start up and thinking, why do I need to use ROS? I would say try without ROS for some time, because you'd understand the basics a lot better. But I would say that the ROS2 is right now capable of getting into the production as well. So then we probably end up coming to ROS2 again, unless there is a very specific need that ROS is not meeting.
Let's steer a discussion from technical to a little bit financial, I might say. So there is a question for Pranavan. So Control One AI has attracted a lot of investments from top names in the industry, like Kunal Shah and top executives, people from iRobot, Tesla, Amazon, Mercedes, and many more. So what does that say? So whenever we hear these big names, we always say, okay, it's a volume game. So what are the insights that you got from these people that are steering your vision towards the Control One AI autonomy stack?
It's a secret. So nothing like that. So probably I should say got some good people around me with whom I was able to discuss ideas, and people who can resonate about the future, how robotics can change future, and how AI can shape up. So, and my previous company's investors, many investors of my previous company also helped us get connected to many people in the industry too. My fundraising journey did not start as a fundraising journey as such. It was more of ideating, talking idea, and discussing to understand how the market, how it will respond, how the market is going to shape up. And luckily, they resonated well with the thought process. And in fact, the first 4 check writers, they technically, we didn't have anything to show or even tell. It was just an idea stage, and they just funded for the idea. So, that's the best part that can happen to any seed stage, pre-seed stage kind of startup too. So, I just feel while you're talking to the right people in the market for a problem which they are facing already and they have seen in the past, and they are able to map it up with a recent development in the field of robotics and AI, and they're able to map what this can bring together. So when that happened, naturally, the investment was a byproduct, I would say. So that happened with the first fundraise. Now we have raised more, but the first, when it was idea stage, totally we raised close to 350K. So everyone on that just plainly made a bet on the idea. And the fact that edge AI inferencing is possible on device, on robot, and they also again believe that a robot, a general purpose technology, a robotic solution for doing multiple things rather than a pre-programmed machine would really help humanity or us to go forward. Yeah. And that happened. Yeah. So it is not like fundraise kind of thing. It's just idea match. That's what I would say.
Great. So talking about general purpose. So nowadays we are seeing general purpose humanoid robots popping up everywhere. And like instead of your case scenarios where your robot works at one particular use case, we see these humanoid robots doing everything.
General purpose, yeah.
Yeah, general purpose. So a humanoid robot can run a tractor. Humanoid robot can do cleaning, everything. So what do you see? These humanoid robots, are they going to capture your AMR markets, or how do you see the future? It's a question for everyone.
Would you like to take?
You want to start?
Let's start with the tractors.
Yeah, I mean, okay.
Let's do tractors first.
So it all boils down to cost, right? So if a humanoid robot, which is becoming like, amazingly popular around the world, and more importantly, it's being like, led by China. We don't hear a lot of things from China, but there is a lot of push from Chinese market as well. So it all comes down to the cost. So let's say you have an electric tractor and it takes you $3,000 more, just a number, to make it autonomously till your land or spray your vineyards, right? Versus a $25,000 humanoid to do the same job. So if your job is super specific, then putting a general solution to that is not the best use of the money, right? But let's say you have a very generic case. You want the tractor to do tilling. You want the tractor to kind of do, storing the grains in the barn, a lot of other activities. Then a little bit more generic and general purpose solution fits there. That makes sense. But so there will be two use cases. You have thousands of acres that has to be tilled, that has to be sprayed. So if it's a very specific, humanoid robots might not make sense directly because the cost of just taking a part of that humanoid architecture and to automate the machine far exceeds the benefit of actually getting a humanoid. But if it's a more general purpose thing, I would say it makes more sense, right? Because you don't need a specified or a specially designed vehicle for it. It could probably technically drive your car as well.
Yeah.
I mean, if once the humanoid reaches its full potential, but it all comes down to the price. That's what it is.
Pranav, do you have to say anything on that?
Yeah, the cost is going to be a primary factor, which being in the field, I at least see 15 to 20 years away to fine-tune the actuators, bring the cost down with mass production, getting the programming AI systems right to move a particular limb to do an action. The cost comes down, then there's a scope because there's a huge hype, and since it's a familiar form factor, people like us might adopt it. I'm not sure. If the cost is good, if it is affordable, and if the model is the pricing model is great, people might use it. But again, it should do the job because as everyone here agrees, there are special purpose machines for every application. I mean, over a period of hundreds of years, decades, like people have fine-tuned machines for a particular application. If you want to plow a field, you have a plow and a tractor. If you want to move a pallet, we have a pallet mower. If you want to, simple thing, right from the tool. If you want to put a driller in the hollow, you have a driller. So the tools have become better and better year on year. So there is always a question, who's going to use this tool? Is either you need to make these tools or machines intelligent, or you need to make a machine to operate these machines because it's designed for humans again. So the question is the world will adopt making these machines intelligent or bringing a humanoid robot which can use these tools? So there is a dilemma there. Well, price is going to decide. That is a huge, that is one of the strongest factors that would prevail because everyone needs cost-effective solution. If I want a humanoid to fold clothes at my home and clean my house, but the first thing that I would compare with the 15,000 rupees or 16,000 rupees part-time maid who can come in the noon, very well fold the clothes, wash the dish and leave. Should I bring a costly machine into a home? So if someone is able to give a 10,000 rupees, hey, you can do these things, you can stay at your home, then the safety factor would come into place, convenience, many things comes into place, and there's a possibility the market would become big.
I'm sure everybody agrees on the price point. Do you have anything to add?
Just
Runal?
one thought is coexistence. I think we'll get into a future where, like Pranav said, these machines have evolved to do a certain thing. So I don't see humanoids being a threat to the AMR industry. I see a lot more interactions and coexistence. It could be, and even if we were to perfect humanoids as general purpose robots, right? We are better off taking them and solving million other problems than come and eat into what we've already solved with autonomy, right? So I just see a lot more coexistence than a threat.
Okay. Runal, you have anything to add?
Yeah, I think everyone's covered it,
Yes.
right? I think our peppermint view is general purpose robots will do general purpose thing, which will have low cadence and low accountability. Hyper specialized or special purpose robots, like the ones we do, we are accountable for the things we do, will be left to special purpose projects and engineering efforts. We would rather have a humanoid robot supervise our fleet of robots.
Okay.
That's a
Good
general
idea.
purpose task.
Nice.
But rather go down and clean a toilet. I don't think that, the and all connecting all the dots, right? The ROI wouldn't make sense. It'll be so generalized. What Pranav said, you'd rather do simplistic tasks for fold my laundry first rather than try to move a more palm or move a tug which has to talk to some PLC which impacts the assembly line of a large manufacturing line. Like there are higher accountabilities here. So we are going to all coexist. Blue, 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 wide ocean.
So just to conclude, I think AMR industry is safe. We are there to grow, and I guess India will be the manufacturing hub for all the upcoming AMRs. With this, I think we can we are open for questions if anybody from audience has any questions for the panelists. Yeah,
There we have one.
there.
Hello. Good afternoon. I have a question to Sriharsha, sir. So, as Pranshu sir asked the question regarding the software, hardware and software, and how you manage to shift from ROS and then again go from there. So, I just wanted to have a follow up. What are the technical challenges that you guys face, like from building your own middleware, then shifting to ROS? Like, what were those key point and challenges, so that I can shed some light on it?
Yeah, sure. I mean, like right off the top of my head, right? It is so easy to just create a topic and just to publish it. So let's say you had a new sensor or you need to understand and stream out a new event. So let's say you're using something like a 0MQ stack. Now you have to create your own port to client connections. It's just so much easier, it's versatile that way. Just the top of my head, right? That is there. Secondly, as I said, right, the ecosystem. For example, if you kind of look at nav2 stack and you want to look at, say, the robot localization package altogether. So there is a lot of historical learning that has gone into making that happen. Recreating is just reinventing the wheel. So sometimes, if you're sure that you're doing a particular thing, and you're sure of your end goals, and you're not going to change things, then it makes sense to kind of do everything yourself, optimize everything, move it to a lot more hardware optimized code as well for it. But when you're talking about autonomous things, especially in field where every farmer has their own sort of requirements, and every farm is also kind of different. So there will be a lot of quick changes that needs to happen. So where we had a challenge as well, because we were in a vineyard, spraying, and then we wanted to quickly change the part of the code, which was like, again, now you need, it's a lot more challenging in that sense.
So can we say like more adaptability is more in ROS?
I mean, especially if you're trying to explore a lot of varieties, and obviously, interfacing with simulation is a lot more easier. Interfacing with gazebo is a lot more easier, for example.
Thank you.
So that makes sense for us.
We can take one more question at the back. Yeah. Yes.
Okay. Hello. Yeah, I also have a question to Harsha. First of all, thank you for a great discussion over here. So we also work in outdoor AMRs. I mean, our sector is also agriculture. So I wanted to know from technical as well as business point of view, what are the challenges which you have faced, and how you have overcome those challenges? Thank you.
Okay, yeah, I think it's a, as you said, right? It's a two-faced question, and it has multifaceted answers. When it comes to agriculture, as I was saying, not all fields are the same, right? And the vehicle has to perform a particular task. So it could be in a slushy environment. You need to pull 4 tons of the spraying, right? And that requires a particular amount of mass. So the vehicles cannot be tiny. They will end up becoming big. So as the vehicle starts becoming bigger, now you need to start adding a lot more batteries on it because you need to power that. And as the battery becomes bigger, battery starts taking almost 50% of your BOM cost, right? And that's just a dead weight, honestly, sometimes. So getting the right product and the price point is very important, especially when you're competing with a diesel alternative. So because if I go and say, hey, my vehicle is 12 lakh rupees, in an AMR sort of an industrial setup, people might be accepting because there is no other option available unless it's a manual one. But here there are, hey, I'm getting an 35 HP tractor at 8 lakh rupees. Why would I want to pay you more if I'm doing the same sort of a thing? So getting the right business and the pricing will become a challenge. So that is something that we have actively been working towards too as well. But when you add a lot of value-added services, that's what we call automation is one. And it's just not automation. So your vehicle is going in a vineyard and it is seeing all the crops, it's seeing the actual grapes. Now we can start doing a lot more things with it. So I see it as a platform, the vehicle as a platform with sensors and a compute and the connection that is there. And it's obviously, honestly, up to the developers that would come on. We would be very happy to work with third-party developers as well. So for example, to kind of do crop health analysis or yield prediction, because the data is there, and so there is a lot more value that we could provide back to our farmers. So addressing these 2 points, right, would kind of help us get into this business as well. Getting the price right and getting the right value.
Thank you, Asha. I guess we can take more questions
one last
offline.
question
Asha,
from this
fine.
side. It's been waiting since long. One last question, guys. We can then take it offline. Thank you.
So hi, Aditya this side. So my question to all the founders is like in autonomous mobile robots, we say we are building collaborative robots, but there are less stringent rules in India as compared to European markets, like they have ISO standards and American markets. So where do you see that when these rules will come in place in India more strictly, and how does it affect like the businesses that you guys have been operating?
Yes.
I'll give a quick 1-second answer to that. It's already happening. I'll speak from the automotive industry standpoint. A lot of automotive manufacturing today, the new greenfield plants that are being set up, one which is great that they're thinking about automation from day zero, but the global exposure today that manufacturing in India has is amazing, which also means standards and expectations around safety. I'm seeing all of that really come in, which I think overall is good. The business side is obviously there's an impact, right? Like when we talk about achieving a certain level of safety, while we're not compromising on safety, there's also an aspect of certification which can be quite an extended process, and there's costs that come with that. But when we're building a product in India, but that's also something that can go global, I think it's inevitable that we build it to just be a global product right from day zero. And that's sort of how we're looking at it.
Thank you, all the panelists. And if we have any questions, you can meet the founders outside, discuss it offline. Thank you very much.
Thank you, Pranshu.
Thank you, Pranshu.